Okay, so right now I'm going to be talking about normal distributions and z-scores. So I'm going to start with normal distributions. A normal distribution looks like a symmetric bell curve graphically. So this would be an example of what a normal distribution looks like for data. And z-scores are used with normal distributions to standardize data. And so you would want to do this because sometimes your data are scaled differently. For an example, SAT and ACT scores, they're scaled really differently, but they're used for the same thing. And I think that's right. 2400. Oops. 2400 on SAT and a 36 on ACT. So for these two scores, that's a perfect score for SAT, and that's a perfect score for ACT. So they're obviously really different, but they both do the same thing. I used to rank kids on their college entrance exams. So although they're different scales, they're meant to represent the same thing. So when you have something like that, you want z-scores to be able to compare them. So what a z-score tells you is the percentile. So let's say you had a bell curve just like that, and while you're let's say you score a perfect 1500. I think that's average for SAT. Yeah. You would score right in the middle, which means your test score was better than 50% of the rest of the people who took the SAT. And that's true because if you refer to your z-table, right at 0, it's 50%. So it's easy to see graphically, but if your score is somewhere other than the middle, you need to refer back to the table and look up what the percentile would be. So we know z-scores are good for standardizing and seeing, calculating the percentile. So I'm going to tell you how to calculate a z-score, which is just z equals x minus the mean over standard deviation. So this is how you would calculate a z-score. Z equals x. X is the observed value. So in the example of a standardized test, x would be your score. And let's say on an SAT it's like a 1725 or something, or 1500. That would go right here in the x. And the mean is the average. And I know the national average for an SAT is 1500. And the standard deviation, I just happen to know it's 300. And so if you plug all that in, that's how you would get your z-score for your SAT score. And so once you know that, you're able to get your z-score, and you're able to look it back up on a table like this. So you would see your z-score. This is the ones place, the tenths place, and the hundredths place, and you just sort of match it up and see which row and column will give you the percentile. And so now that you know how to calculate percentiles using a z-score, I'm going to talk about cutoff points. And what cutoff points do, they're sort of the reverse process of finding a percentile, because cutoff points give you a percentile, and they're asking for unobserved value related to that cutoff point. So we did an example in class where we wanted to see what the cutoff point was at 3% of human temperature. Human temperature on average is like 92 or something like that, and the standard deviation was like 0.76 degrees Fahrenheit. And so what it was asking us to do was find the cutoff point all the way over here at 3%. So you would start by looking up 3% somewhere on the data sheet, then seeing what z-score it corresponds to. And once you have that, you find your z-score, and you're asked to find x. So when you solve for x, you just get this x equals z times standard deviation plus the mean, and that would be your cutoff point. So thanks for watching, and I hope you learned something about z-scores and normal distributions.